Hi, 6th graders. This is the video for lesson 9.1 and 9.2. We are going to combine those two lessons into one. 9.1 is over the introduction to statistics. So we finished chapter 8. We're ready to go ahead and move on to the next chapter. And I think you're really going to like 9.1. Most 6th graders enjoy the fact that we get to use calculators in chapter 9, so you have that to look forward to. In lesson 9.1, I really enjoy. So let's get started. This is just a snapshot out of the book. It says that statistics is the science of collecting, organizing, analyzing, and interpreting data. A statistical question is one for which you do not expect to get a single answer. Instead, you expect a variety of answers, and you're interested in the distribution and the tendency of those answers. So recall that a dot plot uses a number line to show the number of times each value in a data set occurs. Dot plots show the spread and distribution of a data set. Example 1, answering a statistical question. If you conduct a science experiment on house mice and your teacher asks you, what is the weight of a mouse? Is that a statistical question? And explain. Yes, that would be a statistical question because you can anticipate that the weights of the mice will vary. When you ask a question and you know you're going to get various answers, that's a statistical question. Some mice might weigh 18 grams, or some mice might weigh 24 grams, or 28 or 29 grams. All mice, just like all other animals and creatures, are going to be different sizes. That makes it a statistical question. Part B says you weigh some mice and record the weights in grams in the table. So over here on the left, we have this orange table. Then we're going to take all of our recorded weights from the table and display them in a dot plot. So a dot plot is a number line, and then every time a certain value occurs, you put a dot there. The dot plot can help you identify clusters, peaks, and gaps in the data. So we're looking for clusters, which would be like groups of dots together. You can see there's a cluster right here that's circled. The peak is just like it sounds. It would be the tallest, like a mountain peak. And then a gap would be a hole. So the gap is indicated here. So you can see by looking at this dot plot that most of the data are clustered around 20. And the peak is at 20. And there's a gap between 23 and 27. So when you look at the information in a table, it's a little bit harder to kind of see any patterns there. But when you organize it in a dot plot, then you can see, hey, most mice weigh right around 20 grams. You do have some outliers, some bigger ones than that, but most of your mice are going to weigh right around 20 grams. All right, so this next example says the table shows the ages of some people who retired early. You are asked, how old are people who retire early? Is this a statistical question? You should be thinking, yes, this is a statistical question, because you can tell by looking at the table, there is not one single answer to this question. There are a variety of answers to this question, so we know it's a statistical question. Part B says to display the data in a dot plot and identify any clusters, peaks, or gaps in the data. So if we're going to display this data in a dot plot, we need to make a number line. And we have to decide how we're going to number our number line. So as I'm looking through the table, I'm noticing that it looks like the minimum age 56 and the maximum age was 64. So I'm looking through my table, the minimum was 56 and the max was 64. So that's how I'm going to number my number line. And now I'm just going to put a dot every time a number is represented in the table. So I see a 60, I see a 62. I see a 58 and a 59. I see a 61 and a 56. Two more 60s. A 59, a 64, 61, 58, 60, 59, another 60, and a 61. So now that I have my dot plot completed, I'm going to look for clusters, peaks, and gaps in the data. So it looks like most of my data is clustered right around 60. The peak is at 60. And then there's a gap. There's actually two gaps. There's a gap between 56 and 58, and there's a gap between 62 and 64. So using this distribution to answer the question, it looks like most people who retire early are around 60 years old. So students, one thing I want to tell you is just the same way that we can draw a number line vertically, we could do a dot plot vertically. So that is a possibility. You could always do your number line vertically and make your dot plot that way, and you would still be able to see clusters, peaks, and gaps. We're going to go ahead and look at one more example, then we'll move on to 9.2. This example says, the dot plot shows the times of 6th grade students in a 100-meter race. Question A asks, how many students ran in the race? I'm going to give you a minute to think about that, and then I will tell you. I counted 20 students who ran in the race. I just counted the dots. How can you collect these data, and what are the units? So the dot plot shows the times of 6th grade students. So to collect this data, you could just time the students using a stopwatch. And the units look like they're in seconds. 13 seconds, 13.2 seconds, 13.8 seconds, and so forth. And then part C says, write a statistical question that you can answer using the dot plot, and then answer the question. So I'm going to give you a minute to think of a statistical question that you could write using the dot plot. I'm thinking a statistical question could be, how long does it take a 6th grader to run 100 meters? That's a statistical question because you would not expect one single answer. You know you are going to get a variety of answers. And we could answer that question by saying, it looks like most students ran 100 meters in 13.8 seconds. So that covers it for 9.1, 6th graders. You will be ready now to do your 9.1 assignment in Big Ideas. Let's go ahead and go on to lesson 9.2. All right, so lesson 9.2 is about mean. A mean is a type of average. So your keywords here are mean, which is a type of average. You might be familiar with this from 5th grade. You may have done, this might sound familiar if I said mean, median, mode, and range. So that's what we're going to talk about for the rest of chapter 9. So 9.2 is just mean. And to find the mean, or to find the average, you add all of the data in this set and you divide by the number of data values. So for example, if our data set was 8, 5, 6, and 9, we would add 8, 5, 6, and 9 and then divide by 4. So 8 plus 5 plus 6 plus 9 is 28, divided by 4 is 7. And we divided by 4 because there were 4 data values in that set. Looking at example 1, it says finding the mean. The table in yellow shows the number of text messages sent by a group of friends over 1 week. what is the mean number of messages sent? So to find the mean, we're first going to find the sum of all these messages. So we add 120 plus 95 plus 101 plus 125 plus 82 plus 108 plus 90. And we divide by 7 because there are 7 people in this group or 7 data points in the set. So our sum was 721. Divide by 7 and we got 103. So the mean number of text messages sent is 103. Example 2 says the double bar graph shows the monthly rainfall amounts for 2 cities over a 6-month period. So the dark green is city 1 and the lighter green is city 2. We're going to compare the mean monthly rainfalls. So for city 1, we are going to find the sum of all of the dark green bars. So 3.5 plus 2.2 plus 1.9 and so on. There are 6 months represented on the graph. So we find the sum of all the rainfall and divide by 6 for an average of 2.6 inches of rain per month for city 1. For city 2, we're adding all the light green bars. So 1.7 plus 1.6 plus 2.2 and so forth. We will add those and divide that sum by 6. And city 2 gets an average rainfall of 2 inches per month. So we know that city 1 averaged more rainfall. So now we need to talk a little bit about outliers. An outlier is a data value that is either much greater or much less than the other values. When your outlier is included in your data set, it can affect your mean. So if you have one outlier that is much greater than most of the other values, it can raise your mean, and it may not give you a very accurate view of your data. So if we look at the heights of the Shetland ponies in inches, looking at this orange table, which data set do you notice is the outlier? Sometimes it's hard to tell by looking in the table. So again, if you organize your data from the table into a dot plot, that makes it easier to find the outlier. Looking at the dot plot, it's really easy to see that all of your data are clustered over here between 37 and 42, and this one outlier is way down at 28. So the directions on part B say to find the mean with and without the outlier. If we're going to find the mean with the outlier, we're going to add 28 plus 37 plus 37 plus 38 plus 38 plus 39 plus 40 plus 40 plus 40 plus 42, and we're going to get a sum of 379 and divide by 10 because there are 10 data points. That gives us an average height of 37.9 inches. The mean without the outlier, we're not going to include 28. So we're going to add all of the other data and then divide by 9 because now there are 9 data points in our set. And we get a mean of 39. So notice what happens to our mean when we include the outlier and we do not include the outlier. If we include the outlier, which is much shorter or much smaller than the others, it brings our mean down. If we take that outlier out, then our mean is higher. So I can see that that outlier really affects my data. With the outlier, the mean is less than all but 3 of the heights. And without the outlier, the mean better represents the heights. 2 more examples and then I will let you go work on your assignment. These examples say for each data set, identify the outlier, then describe how it would affect the mean. So number 3 is weights in pounds of dogs at a kennel. We have 48, 50, 55, 60, 8, 37, and 50. The outlier is obviously the smallest value, which is 8. And if you were going to include 8 in your mean, it would bring your mean down. Next, we have prices for flights from Miami to San Juan, Puerto Rico. Look for the outlier in that data set. You should have noticed that the outlier is 900. That price is quite a bit higher than the other prices. And if you were going to include that in your mean, it would make your mean price much greater. So kiddos, that concludes this video for 9.1 and 9.2. You are ready to go ahead and begin working on those assignments.